Let's start with something interesting. 6 accidental discoveries that changed human history forever. Number 6. X-rays. What if one of the most important medical tools in history was discovered by accident in a dark room? In 1895, German physicist Wilhelm Conrad Röntgen was experimenting with cathode rays, streams of electrons traveling through vacuum tubes. He wasn't trying to revolutionize medicine. He was studying electricity and radiation, something many scientists of his era were investigating. Then something strange happened. While working in his lab, Röntgen noticed that a fluorescent screen across the room began to glow, even though the cathode ray tube was covered. The light shouldn't have reached it. The tube was shielded. Something invisible was passing through. Curious, Röntgen darkened the room and repeated the experiment. The glow returned. Whatever these rays were, they could pass through cardboard, paper, even thin sheets of metal. He called them X-rays, with X representing the unknown. To test their properties, he placed his wife's hand between the tube and a photographic plate. When the image developed, it revealed something no human had ever seen before: the bones of her hand and the outline of her ring. For the first time in history, the inside of a living human body had been captured without surgery. The impact was immediate. Within months, hospitals across Europe and America were using X-rays to locate fractures, bullets, and internal abnormalities. Surgery became more precise. Diagnosis became less guesswork. Röntgen had not set out to transform medicine. He had stumbled into it. The discovery reshaped science, warfare medicine, dentistry, and later fields like airport security and crystallography. It also opened the door to understanding radiation's risks and benefits. What began as a laboratory curiosity became a cornerstone of modern healthcare, an invisible force, found by accident. That allowed humanity to see beneath its own skin, and once we saw inside the body, medicine would never be blind again. Number 5. Penicillin. What if one of the greatest medical breakthroughs in history began because someone forgot to clean a petri dish? In 1928, Scottish bacteriologist Alexander Fleming returned to his laboratory at St. Mary's Hospital in London after a vacation. On his workbench sat several petri dishes containing Staphylococcus bacteria, and one of them looked contaminated. Most scientists would have thrown it away immediately. But Fleming noticed something strange. A patch of mold had grown on the dish, and around that mold, the bacteria had died. The area surrounding the fungus was clear, a visible halo where microbial life had been destroyed. Instead of discarding the mistake, Fleming leaned in. The mold was later identified as Penicillium notatum. It was releasing a substance that killed bacteria. Fleming realized he had accidentally discovered the first true antibiotic. He named it penicillin. At the time, infections were often fatal. Minor cuts could lead to deadly sepsis. Pneumonia, syphilis, and wound infections killed millions. Surgery was risky not because of the procedure, but because of post-operative infection. Penicillin changed that. Though Fleming struggled initially to purify and mass-produce the drug, and other scientists later refined the process during World War II. By the 1940s, penicillin was being manufactured at scale, saving countless wounded soldiers from infection. The impact was historic. Mortality rates from bacterial infections plummeted. Life expectancy increased. Modern medicine transformed. And it all began with contamination. A forgotten dish. A patch of mold that shouldn't have been there. Fleming himself later admitted that the discovery was partly luck, but it was the kind of luck that required observation, curiosity, and restraint. The willingness not to throw away a mistake too quickly. Penicillin didn't emerge from a perfect experiment. It grew from an accident. And it ushered in the antibiotic age, forever altering humanity's relationship with disease. Number 4. Radioactivity. What if one of the most powerful forces in nature revealed itself? By accident in a drawer. In 1896, French physicist Henri Becquerel was studying phosphorescent materials, substances that glow after being exposed to sunlight. Inspired by the recent discovery of X-rays, he wanted to see if glowing minerals might emit similar invisible rays. His experiment seemed simple. He placed uranium salts on top of photographic plates wrapped in black paper, intending to expose them to sunlight first. The idea was that sunlight would energize the crystals, which might then emit radiation strong enough to penetrate the paper and expose the plate. But the weather didn't cooperate. Paris was cloudy for several days. So Becquerel postponed the experiment and stored the prepared photographic plates in a drawer, still wrapped, still unexposed to sunlight. When he later developed the plates anyway, expecting nothing, he was stunned. They were strongly exposed. The uranium had emitted radiation without any sunlight at all. It was spontaneous. Invisible energy was coming directly from the element itself. Becquerel had not discovered a glow triggered by light. He had uncovered radioactivity. This accidental observation shattered assumptions about atomic stability. Until then, atoms were believed to be indivisible and unchanging. But radioactive materials proved that atoms could release energy from within. The implications were enormous. Radioactivity became central to the work of Marie and Pierre Curie, leading to the discovery of new elements like radium and polonium. It eventually paved the way for nuclear physics, nuclear medicine, and atomic energy. It also introduced new dangers. Radiation could heal and harm. What began as a cloudy day inconvenience became one of the most transformative scientific discoveries of the 19th century. Becquerel wasn't searching for atomic instability. He was following a small curiosity about glowing crystals. But by leaving photographic plates in a drawer, he opened the door to the nuclear age. An accident. That changed physics forever. Number 3. Cosmic microwave background. What if the sound that proved the universe had a beginning was first dismissed as static? In 1964, two radio astronomers, Arno Penzias and Robert Wilson, were working at Bell Labs in New Jersey. Their goal was practical, not cosmic. They were testing a large microwave antenna designed for satellite communications. But something kept interfering with their measurements. A persistent hiss. Just no matter where they pointed the antenna, day or night, city or sky, the noise remained. It was faint but constant. They checked everything. Faulty wiring, instrument error, atmospheric distortion. Even pigeon droppings inside the antenna were removed just in case. The noise didn't disappear. It came from every direction in space. At the same time, a separate team of physicists nearby had been developing a theory. If the universe began in a hot, dense explosion, what we now call the Big Bang, there should still be leftover radiation lingering across the cosmos. Not visible light, but a faint microwave glow, cooled over billions of years as the universe expanded. When the two groups connected their findings, the static suddenly made sense. Penzias and Wilson hadn't discovered interference. Say they had detected the cosmic microwave background radiation, the afterglow of the Big Bang itself, light that had been traveling for nearly 14 billion years. This discovery provided some of the strongest evidence that the universe had a beginning. Before this, many scientists believed the universe was eternal and unchanging. The steady-state theory competed seriously with the Big Bang model. But the static settled the debate. The universe had once been hotter, smaller, and denser, and it was still expanding. Penzias and Wilson weren't searching for the birth of the cosmos. They were troubleshooting equipment. But in trying to eliminate noise, they uncovered the oldest light in existence. An accidental discovery that proved the universe had a beginning. Number 2. Insulin. What if a single lab experiment could turn a death sentence into a lifelong condition? Before 1921, a diagnosis of type 1 diabetes was almost certain death. Children and young adults diagnosed with the disease often survived only months. Doctors could offer little more than extreme starvation diets to slow the inevitable. Patients wasted away as their bodies failed to regulate blood sugar. Then came a late-night idea. Frederick Banting, a young Canadian doctor, had been reading research about the pancreas. Scientists suspected it produced a substance that controlled blood sugar, but extracting it without destroying it had proven nearly impossible. One night, Banting scribbled a rough idea in his notebook. Tie off the pancreatic ducts in dogs, allow certain cells to degenerate, and isolate the remaining internal secretion. It wasn't elegant. It wasn't guaranteed, but it was enough to try. Working with medical student Charles Best in a small lab in Toronto, Banting began experimenting. After months of trial and error, they extracted a substance that lowered blood sugar in diabetic dogs. Then came the real test. In 1922, a 14-year-old boy named Leonard Thompson, dying from diabetes, became the first human to receive insulin injections. His blood sugar dropped. His strength returned. The wasting stopped. For the first time, diabetes wasn't immediately fatal. It became manageable. Insulin therapy rapidly spread worldwide. Pharmaceutical production scaled up. What had once been a swift and tragic decline became a chronic condition people could live with. The impact cannot be overstated. Millions of lives extended. Children who would have died grew up. Their families stayed whole. Banting hadn't stumbled onto insulin completely blindly, but the breakthrough came from a risky experimental approach many had overlooked. A scribbled idea, a small lab, a desperate test, and a substance that changed medicine forever. A lab test saved millions, and diabetes was never the same again. Number 1. European discovery of America. What if one of the most world-changing discoveries in history began with a navigation mistake? In 1492, Christopher Columbus set sail under the Spanish crown with a simple objective: reach Asia by sailing west. European powers were desperate for faster trade routes to the riches of the East: spices, silk, gold. Columbus believed the Earth was smaller than most scholars calculated. If he sailed far enough west, he thought he would arrive in Asia. He was wrong. After weeks at sea, his ships reached land in the Caribbean. Columbus believed he had arrived near Asia and referred to the inhabitants as Indians, a mistake that would echo through history. He had not reached Asia. He had reached a continent previously unknown to Europe. The Americas were already home to millions of indigenous people with complex societies, trade networks, and civilizations. But for Europe, this voyage shattered geographic assumptions. Maps were redrawn, trade routes transformed, exploration intensified. The consequences were enormous. European powers rushed to claim territory. Colonization accelerated. Entire empires rose and fell as Spain, Portugal, Britain, France, and others competed for control. The transatlantic slave trade expanded. Indigenous populations were devastated by disease and conquest. Where global power shifted. The Columbian Exchange began, a massive transfer of crops, animals, culture, and disease between the Old World and the New. Potatoes, tomatoes, and maize reshaped European diets. Horses transformed the Americas. Economies reorganized. Borders that still define nations today were eventually drawn from this chain reaction. Columbus did not intend to discover a new continent. He intended to find Asia. But his navigational miscalculation triggered one of the most consequential turning points in human history. The modern global order, politically, economically, culturally, traces back to that voyage. He missed Asia, found a continent, and the world was never the same.